Welcome back for another deep dive. This time, we're going to unpack web analytics.
Sounds good.
We've got some fascinating lecture slides here and even some tutorial packs about web and social media analytics. We're going to be talking about web metrics, HTTP cookies, page tags, and even search engines.
Should be interesting.
Yeah, I think so. I think a lot of people, maybe even myself, think web analytics is just about, counting how many people visit a website.
Yeah, a lot of people think
Is
that.
that really all it is, though?
Oh, definitely not. It's much more than just counting visitors. Web analytics is about understanding how users interact with a website. What pages they visit, where they click, how they navigate. It's all about trying to understand that digital journey so websites can improve their content, their design, and ultimately serve you better.
So it's about understanding behavior.
Exactly.
Okay. Well, the lecture slides actually mention different levels of web analytics. Like there's basic benchmarking, which is looking at how a website's doing today versus yesterday. There's optimization, using data to make the website better. And then there's advanced marketing, which uses web data to inform all marketing efforts.
That's right.
So there's a lot of different ways you can use this data.
Yeah.
The lecture slides also mention something called web metrics.
Right.
Can you explain what those are?
Yeah, web metrics are basically measurable values that help us understand how effective a website is. Think of them as like KPIs for the online world, key performance indicators. They help us track progress towards specific goals.
Okay, KPIs, got it.
Yeah.
But are these KPIs, these web metrics, I should say, do they apply to all websites the same way? Or does it depend on what the website's trying to do?
That's a good question. The importance of different metrics can definitely vary depending on what the website is trying to achieve. For example, an e-commerce site might focus on its conversion rate, so that's how many visitors actually buy something. But a news website might prioritize page views or like how long people are spending on each article.
So different websites, different priorities.
Yeah, not one size fits all.
So what are some examples of these web metrics?
Well, there's three main categories. You have acquisition, engagement, and conversion. Acquisition metrics tell us how users are finding the website if they're coming from search engines, social media, or if they're typing in the URL directly.
Okay.
Engagement metrics measure how users interact with the site once they're there. Things like bounce rate, which tells us how many people just leave after viewing only one page.
Right.
And then conversion metrics, those track whether visitors are completing desired actions, such as buying something or signing up for a newsletter.
Okay, so acquisition is about getting people to the site.
Yeah.
Engagement is keeping them there.
Right.
And conversion is about getting them to do something valuable.
Precisely.
It's like a funnel, right?
Yeah, that's a great way to think about it.
Yeah.
A funnel guiding visitors towards a specific goal.
But how do they actually gather all this information about us? It's not like they have cameras on us or something, right?
No cameras. But they do have some pretty clever ways of tracking user behavior.
Like what?
Well, the two main methods are web server logs and page tags.
Web server logs. Yeah, the lecture mentioned those. It's like websites are detectives, and these logs are their case files.
That's a great analogy. Every time you request something from a website, like a web page, image, or video, the web server records that request in a log file. And that file's like a detailed record of what happened. It's got the user's IP address, the time of the request, and the resource that was requested.
So they can tell a lot about, who's visiting and what they're looking at.
Yeah.
But the lecture also mentioned page tags.
Right.
How do those work?
Well, page tags are small snippets of code that are embedded directly into the web page. And they act like these tiny little sensors, collecting data about user interactions as they happen. Think of them like invisible observers, tracking things like scrolling, clicking on links, or even filling out forms.
So whereas web server logs are tracking the requests, page tags are capturing what they're actually doing within the pages.
Exactly. Page tags allow websites to gather very granular data, like how long somebody spends reading a specific section of an article or what they type into a search bar, even if they don't submit the search.
Wow. It's amazing how much information can be collected.
Yeah.
The lecture slides also mention something called HTTP cookies, or just cookies.
Yeah.
What role do cookies play in all this?
Well, cookies are essential for tracking user activity across multiple visits to a website. Remember, the web is stateless, which means that every interaction is treated like a brand new one. It's like the website has amnesia. It forgets you were ever there once you leave.
Right, because if you treated everyone like a new visitor every time, that wouldn't be very helpful.
Exactly.
So cookies are like the memory.
Yeah, they're like little reminders helping the website remember who you are even after you've closed the browser. So when you visit a website, the server sends a cookie to your browser, which stores it on your computer. And this cookie contains a unique identifier that allows the website to recognize you when you return.
Right.
And this is how websites remember things like what's in your shopping cart or your login information, even if you haven't actually logged in.
So cookies are what allow websites to provide those personalized experiences we've all become used to.
That's right.
But cookies can also be used for tracking purposes, which kind of leads to some privacy concerns.
Definitely.
We're going to delve into that a bit later in this deep dive.
Sounds good.
We've talked about how websites collect all this data, but what can they actually do with this information? It's not just about spying on us, right?
No, of course not. This data is actually incredibly valuable for understanding user behavior and optimizing websites to better serve their visitors.
Okay.
One of the most powerful applications of all this data is something called clickstream data.
Clickstream data, I've heard that before. Is that like following the trail of clicks a user makes, as they navigate a website?
Exactly. By analyzing that sequence of pages visited, where they click, how long they stay on each page, websites can gain a lot of valuable insight into their preferences and their pain points.
So it's like having a map of their digital journey,
That's right.
highlighting the areas where, I don't know, maybe they get lost or frustrated.
Precisely.
So for instance, if I'm constantly clicking on, I don't know, the shoes category, but I never actually buy anything, the website might be able to figure out that, maybe they need to improve their checkout process or maybe offer free shipping to encourage me to actually buy something.
Exactly. And clickstream data is also invaluable for digital marketing campaigns. By understanding how people arrive at a website and what actions they take, marketers can tailor their campaigns to be much more effective.
So it's all about understanding the user experience and then using that to make things better.
That's right.
The lecture also mentions A/B testing in this context.
Yeah.
Can you remind me what that is again?
Yeah, so A/B testing is basically a way for websites to experiment with different versions of a page to see which one performs better. For example, they might show version A of a landing page to half of the visitors and version B to the other half, and then they compare the conversion rates to see which version was more effective.
So it's like a scientific experiment.
Exactly. It's a data-driven approach to website optimization, constantly testing and refining to create the best possible user experience.
I like that. It's like the website's always learning and evolving, always trying to be better,
Yes.
but having data is only the first step, right?
You're absolutely right. It's what you do with the data that really matters.
Right.
And that's where KPIs come in, key performance indicators. KPIs are the specific metrics that a website uses to measure its progress toward its goals.
So they're like the website's version of New Year's resolutions, helping them stay focused and on track.
That's a great way to think about it. And just like with New Year's resolutions, it's important to choose KPIs that are actually relevant, measurable, and achievable.
The lecture slides mention something called a balanced scorecard approach to KPIs.
Right.
What does that mean?
Well, the balanced scorecard approach ensures that the KPIs cover a range of critical areas, not just financial performance. So it's about looking at the bigger picture and considering multiple perspectives.
So it's not just about making money, but also about providing a good experience to the users, engaging with your audience, achieving your business goals.
Exactly. For each KPI, it's crucial to identify the source of the data, how often it should be measured, what the target is, and how it aligns with the organization's overall strategy.
Okay, so real-world example here.
Sure.
The lecture slides actually include a case study about Transport for London.
TfL?
Yeah, TfL. So that's the folks who run the London Underground, the buses, all that.
Right.
One of their long-term goals was to improve their customer support and be ranked in the top 10 for customer satisfaction. Well, they noticed an increasing number of calls to their helpline, and people would often wait a really long time to get answers.
Not a good sign.
Not good, not good. It turned out that a lot of these calls were actually about planned engineering works,
Right.
which, is information that's already on their website.
Right.
The problem wasn't that the information wasn't there.
Uh-huh.
It was that people couldn't find it.
Right.
So they decided to use web analytics to track how many people were actually viewing that page, the planned engineering works page.
Makes sense.
So they identified their data source, decided to measure it weekly, set a target for how many visitors they wanted to see the page, and aligned this KPI with their overall goal of improving customer support.
So by tracking this specific metric, they could see if their efforts to make the information more accessible were working.
Right, because if people could find the information online, they wouldn't need to call the helpline,
Uh-huh.
which would improve customer satisfaction and also reduce wait times.
Exactly. It's a great example of how web analytics can be used to actually solve real-world problems and achieve tangible results.
Okay, so we've got our KPI defined, and we're getting all this data. What happens next?
Well, that's where the real work begins, turning data into action. This might involve experimenting with different website designs or different content, different marketing campaigns. For example, if TfL's data showed that people were still having a hard time finding the engineering works information, they might redesign that section of the website, or maybe create more prominent links to it from other pages.
So using the data to make informed decisions and constantly iterating based on the results.
Exactly. And this brings us to another important concept, attribution modeling.
Oh yeah, attribution model.
Attribution modeling is all about figuring out which marketing efforts deserve credit for those valuable conversions.
I remember reading about that in the lecture slides. It's not always a straightforward answer, especially when someone interacts with multiple marketing channels before making a purchase. So let's say I see an ad on social media for, cool new pair of shoes.
Okay.
Well, I click on the ad, but I don't buy the shoes right away.
Okay.
Later that day, I search for the shoe brand on Google. I click on their website, and then I finally decide, okay, I'm going to buy these shoes.
Right.
So how do we know whether it was the social media ad or the Google search that deserves the credit for that sale?
That's exactly the challenge attribution modeling tries to solve. It's about assigning value to different touch points in the customer journey.
So depending on the model you choose, you might give more credit to the first interaction, the last interaction, or spread the credit across all the different touch points based on their perceived importance.
Exactly. And the choice of which attribution model to use depends on the organization's goals and how they value the different touch points in that customer journey. For example, a company that prioritizes brand awareness might favor a first-click attribution model,
Okay.
while a company focused on immediate sales might prioritize the last interaction that led to the purchase.
It's like a detective trying to reconstruct a crime, figuring out which clues were the most important.
That's a great analogy.
Speaking of clues, let's talk about search engines. They're like the gatekeepers of the web,
Yeah.
deciding which websites get seen and which ones don't.
They play a huge role in driving traffic to websites.
And it all comes down to SEO,
SEO, that's right.
search engine optimization. It's the art of making your website irresistible to those all-powerful algorithms.
Exactly. It's about understanding how search engines work and then tailoring your website to rank highly in the search results.
So it's not just about, stuffing your website with keywords anymore.
No, definitely not. Search engines have gotten a lot smarter over the years. They use these sophisticated algorithms to assess the quality and the relevance of web pages. For example, Google's famous PageRank algorithm. That takes into account factors like inbound links from other websites.
So like the more high-quality websites that link to your website, the higher your PageRank score and the better your chances of ranking well.
That's a good way to put it. But SEO is also about creating high-quality content that's relevant to what people are searching for.
Right, because if someone searches for, I don't know, the best chocolate chip cookie recipe, Google wants to show them websites that actually have delicious recipes,
Right.
not just pages that are full of the words chocolate chip cookie.
Exactly. User experience is paramount. Search engines want to deliver the best possible results to their users.
Right, because happy users means more people using their search engine, which is good for business.
That all makes sense.
Now, besides SEO, the other big player in the search engine world is PPC, or pay-per-click advertising.
Right.
Those are the little ads that show up, at the top of the search results page.
The ones that try to tempt you.
Yes. With those amazing deals and limited time offers.
Precisely.
PPC is a powerful tool for businesses to reach their target audience quickly and directly.
It is.
And it's all about bidding on keywords.
Yeah, that's right. Advertisers choose keywords that are relevant to their business and then they bid on them. When someone searches for one of those keywords, the ads from the highest bidders are displayed.
So it's an auction for eyeballs.
Yeah, that's a very apt description. And it's a highly competitive market with businesses constantly adjusting their bids and their strategies to stay ahead.
Oh, I bet.
Yeah.
But PPC can be very effective, especially for new websites that haven't had time to build up their organic search ranking.
Absolutely. It's a great way to jumpstart your visibility and drive traffic to your site.
We've covered SEO and PPC, the two titans of the search engine landscape. But what about recommendation systems?
Ah, yes. Recommendation systems, those are the clever algorithms that suggest products, content, or services that you might be interested in.
Like when Netflix suggests movies based on what you've watched before, or Amazon recommends products that you might also like.
Exactly. They're designed to personalize your online experience and, of course, encourage you to spend more time and money on the platform.
Well, personalized suggestions can be pretty helpful. How do these recommendation systems actually work?
There are a few different approaches, but the most common ones are collaborative filtering and content-based filtering.
Okay, break it down for me.
All right.
What's collaborative filtering?
So collaborative filtering is based on the idea that people with similar tastes tend to like similar things.
Okay, so if I consistently watch like the same documentaries as you, the system might recommend a documentary that I haven't seen, but that you've rated highly.
Exactly. It's like getting recommendations from a friend with really good taste.
I like that. What about content-based filtering?
Well, content-based filtering analyzes the features of items that you've interacted with in the past.
So if I've bought like a lot of science fiction books, the system might recommend other science fiction books, even if they're by authors I haven't read before.
Precisely. It's all about finding those patterns in your past behavior and using that to predict your future preferences.
It's a bit like having a personal shopper who really knows your style.
Yeah, and of course, there are also hybrid systems that combine both collaborative and content-based filtering to create even more sophisticated recommendations.
The more data, the better the recommendations, I guess.
In many cases, yes, but it's also important to strike that balance between personalization and privacy.
Yes, the elephant in the room.
Right.
We've talked about how websites gather all this data and use it, but what about protecting our personal information?
Privacy is paramount.
Yeah.
And it's definitely a complex issue with no easy answers. On one hand, we want those personalized experiences and helpful recommendations.
But on the other hand, we want to make sure our data is not being misused. We don't want to feel like we're constantly being tracked.
Precisely. It's a very delicate balance, and it's one that websites and policymakers are, they're grappling with constantly.
The lecture slides mention some potential risks associated with all this data collection.
Right.
One of the biggest concerns is unauthorized tracking.
Uh-huh.
The potential for misuse of this data, especially if it gets into the wrong hands. So, like, my browsing history could be used to target me with, I don't know, like manipulative advertising.
It's definitely a possibility.
Or even worse.
Yeah, and it's something that privacy advocates are fighting very hard to prevent. Another big risk is user profiling.
User profiling.
Yes.
That sounds a bit ominous.
Yeah, it refers to the practice of creating these detailed profiles of users based on their online behavior.
So websites are like building this digital version of me with all my likes, dislikes, and habits.
In essence, yes. And this information can be used for various purposes. Some of them are benign.
Okay.
Some less so.
Right. Like, they might show me targeted ads or give me personalized recommendations. But I guess it could also be used to, I don't know, like discriminate against me or influence my decisions in ways I'm not even aware of.
Those are valid concerns, and they highlight the need for transparency and control over our own data.
And of course, we can't forget about the ever-present threat of data breaches.
Right. Data breaches are a major problem. They expose vast amounts of sensitive user data.
So, like, even if a website has good intentions, maybe their security measures aren't strong enough to prevent a data breach.
Yeah, and then all that data could end up being used for, purposes that were never intended.
Right, for nefarious purposes.
Exactly.
It's definitely a risk we need to be aware of. So what's being done to protect our privacy in this data-driven world?
Well, thankfully, there are several initiatives and regulations in place.
Like what?
Well, you mentioned GDPR earlier.
GDPR.
The General Data Protection Regulation, that's definitely a major step forward.
Can you remind me what that is again?
Yeah, so the GDPR is a regulation in the European Union that gives individuals more control over their own personal data. It includes rights like the right to access, rectify, erase your personal data, and the right to data portability.
So I have the right to know what data a company has collected about me.
Yes.
I can correct any inaccuracies.
That's right.
And even demand that they delete it.
That's right. The GDPR also requires companies to be more transparent about how they collect and use data, and they need to get explicit consent from users before they can collect certain types of data.
So no more of those sneaky tracking cookies without my permission.
In theory, no. GDPR actually has teeth. Companies that violate those regulations can face huge fines.
That's good to know. Are there any other techniques being used to protect our privacy?
One promising approach is called anonymization. So this involves basically stripping the data of any personally identifiable information, so it's impossible to link it back to a specific person.
So instead of knowing that, John Smith bought a certain product, the data would just say, like, a user in London bought it.
Exactly. It allows companies to get those insights from the data without compromising individual privacy.
It's a great solution.
Another important concept is data minimization.
Data minimization. So collecting only the essential data needed for a specific purpose.
Precisely. It's about reducing the amount of data collected in the first place, which lowers the risk of privacy violations.
It's like the digital version of less is more.
Yes, exactly.
Wow, we've covered a lot of ground today. We've gone from web server logs to page tags, from clickstream data to KPIs, even touched on the ethical considerations of privacy in this data-driven world.
It's been quite a journey.
Yeah. I'm feeling a little overwhelmed, if I'm being honest.
It's a lot to absorb, I understand.
But the key takeaway is that web analytics is this really powerful tool, and it can be used for good or for bad, right?
That's right.
It all depends on how it's used and who's using it.
Exactly.
Why don't we take a break, and then we can come back to finish this deep dive into web analytics. We still have to unpack marketing funnels and how websites use clickstream data in practice.
Sounds good to me.
All right, let's jump back in. Before the break, we were talking about using data to improve websites and track marketing efforts. One of the things that came up was marketing funnels.
Yes.
What exactly is a marketing funnel?
Well, you can think of a marketing funnel as a visualization of the customer journey, from that first moment they discover a product to the point where they actually make a purchase.
Okay.
It's a really helpful way to understand how people move through these different stages, like awareness, interest, consideration, and then finally the conversion.
Right. The lecture slides mentioned a specific model, something called Ash's marketing funnel.
Yes.
Can you tell us a bit more about that one?
Sure. So Ash's model basically highlights the different stages that a potential customer goes through, specifically in the digital marketing landscape.
Okay.
So it starts with attracting prospects through different channels like email, affiliate links, social media campaigns.
So it's kind of like you cast a wide net to grab people's attention.
Exactly. And then as those prospects learn more, become more interested, the funnel narrows.
Okay.
They move through those stages: awareness, interest, and consideration. And finally, some of them will convert, meaning they take a desired action like buying a product.
This makes me think about clickstream data, right? Could you use clickstream data to track users as they move through this funnel and maybe identify any areas where they might be getting stuck or dropping off?
Absolutely. That's a great point. Clickstream data is incredibly valuable for understanding how people navigate a website and where they might be running into difficulties.
Yeah.
For example, if we see that a lot of users are abandoning their shopping carts at the payment stage,
Right.
well, that could indicate that there's a problem with the checkout process. Maybe it's too complicated. Maybe the shipping costs are too high.
Right, like a detective looking for clues.
Exactly. By analyzing the clickstream data, we can identify these bottlenecks and make changes to optimize the funnel, ultimately leading to more conversions.
Okay, so the tutorial packs actually had some interesting information on this as well. One of the exercises focused on web server log files.
Right.
So those detailed records of every request made to the server. You mentioned earlier that these logs are important for understanding user behavior.
Yeah, they're a gold mine of information.
But what are, like, the advantages and disadvantages of using them?
Well, web server logs are definitely a valuable data source, but like anything, they have their pros and cons.
Yeah.
A major advantage is that they're pretty easy to set up.
Yeah.
Often it's just a simple configuration change on the server.
So you don't need, like, a degree in computer science to start collecting this data.
No, not at all. Another advantage is that they capture requests for all types of files, not just HTML pages.
Okay.
This includes things like images, videos, and other resources that users might download.
Right, so you get a much more complete picture of their activity, not just, what pages they looked at.
Exactly.
Why is that important?
Well, it helps us understand their behavior in more detail. For example, if we see a lot of people are downloading a specific PDF from our website, well, it might indicate that we need to make that information more prominent, more accessible.
That's a great point. The tutorial also mentioned that web server logs don't rely on JavaScript, which can actually be a good thing.
Right.
Can you explain why that is?
Sure. So some users actually disable JavaScript in their browsers for privacy reasons or to improve performance. And if you're relying on JavaScript for tracking, you might miss out on data from those users.
Okay.
Web server logs, on the other hand, They rely on the server's own logging mechanisms, which are totally independent of JavaScript.
So it's a more reliable way to capture data from everyone, no matter what their browser settings are.
Exactly.
Okay, but what about the downsides of these web server logs? I mean, the tutorial did mention needing admin access, potential performance issues, limited data about the user.
Right. There are some downsides to keep in mind. Firstly, to access the web server logs, you usually need administrative privileges on the server. And that's not always feasible, especially for smaller businesses that might be using shared hosting where they don't have full control.
So it's not as simple as, flipping a switch if you don't have the right permissions.
Right.
Okay, what about the performance impact?
Well, logging every single request can put a strain on the server's resources, especially if the website's getting a lot of traffic.
And this could potentially slow down the website for everyone.
You're right. You don't want to be slowing things down.
Exactly. Websites need to find that sweet spot between collecting valuable data and ensuring that the user experience is still smooth.
Okay, and what about the limited user data?
Yeah, so web server logs by themselves only provide basic information about the user,
Okay.
like their IP address and what resources they requested.
Right.
They don't tell us anything about what the user actually did on the page, like how far they scrolled or which links they clicked on.
So because we see the footprints, but we don't know what they were actually doing.
That's a great way to put it. And this is where page tags can come in to kind of fill in those gaps.
Page tags to the rescue. The tutorial pack goes into detail about the pros and cons of those as well.
Yeah.
Highlighting their ability to capture more detailed data, the wide variety of tools available.
All right.
However, it also mentions they only track HTML files, potential slowdown of page loading times, and they require coding on all pages. Right. Page tags have their own set of advantages and disadvantages. Because they're basically snippets of JavaScript code, they mainly track interactions that happen within HTML pages. They might not capture things that happen outside of that HTML context, like if a user downloads a PDF file that's linked from the page.
Okay, so if someone clicks on a link to go to an external website, the page tag might not track that.
That's correct.
Okay.
So it's important to be aware of those limitations when you're interpreting the data. Another consideration is that they can slightly increase the page load time because the browser has to execute that extra code.
Yeah, I've definitely noticed that some websites can be really slow to load, and it's super frustrating.
Oh, absolutely.
So does that mean we should just avoid using page tags altogether?
Not necessarily.
Right.
It's about finding the right balance. While they do add a little bit of overhead, they also give you very valuable insights that you can use to improve the website and the user experience.
Right.
And if those insights lead to, let's say, more conversions or a more engaged audience, then that tiny increase in load time might be worth it.
It's a trade-off, speed versus functionality.
Exactly.
The tutorial also mentions the need for coding on all pages, which sounds like it could be a bit of a hassle for web developers.
It can be, especially for bigger websites with lots of pages. Implementing and testing these tags correctly, it takes careful planning, making sure they don't interfere with other website functions.
Now, again, it's a balancing act. You want that rich data, but it can get complex.
Yeah.
Speaking of tools, the tutorial also highlights the importance of software tools for calculating and monitoring these web metrics.
Right. These tools automate a lot of that data collection and analysis, which can save you a ton of time and effort.
What are some of the key differences we should be looking out for when choosing a web analytics tool?
Well, there are several things to consider. The features that are offered, the data collection strategy that's used, the data storage methods, and of course, the price.
So some tools might be more comprehensive, while others might be more specialized. Some might use web server logs, others might use page tags, and some might be free, while others require a paid subscription.
Exactly. The tutorial actually mentions Google Analytics as the most popular tool out there.
Oh yeah, I've definitely heard of that one.
Yeah, and I imagine that's because it's free to use, very user-friendly, and it offers a really wide range of features.
So even someone, who doesn't have a lot of technical expertise could start using Google Analytics and get some valuable insights about their website.
Absolutely. But it's important to remember that Google Analytics isn't the only option out there.
Right.
The tutorial also mentions AW Stats and Go Access as popular alternatives.
Okay.
And these are both open source tools, which means they're free to use and often have a strong community of developers supporting them. They provide really robust features for analyzing web server logs.
So what are their specific strengths? Why might I choose one over the other?
Well, AW Stats is great for getting detailed reports on your website, traffic, visitor demographics, and other key metrics.
Right.
So it gives you a comprehensive overview of your website's performance. Go Access, on the other hand, focuses more on providing real-time analytics.
So AW Stats is like a historical record,
Yeah.
and Go Access is like a live dashboard.
Exactly. It all comes down to choosing the right tool for your specific needs.
Right, because we have all these options available, each with their own pros and cons.
But no matter which tool you choose, the most important thing is that you actually use the data to make informed decisions.
Right, because data without action is meaningless.
Exactly.
You need to be able to interpret the data and use it to improve your website and achieve those goals.
That's right. And those decisions should be driven by the website's KPIs, and those overall business goals.
Okay, I think I'm ready to move on to another topic from the lecture slides. Statistical significance. Now, statistical significance, this is crucial in web analytics, especially when you're conducting A/B testing, right? We need to know if the differences we see between those two versions of a web page are actually meaningful or just random fluctuations.
That's right.
So how do we figure out if a difference is statistically significant?
Well, that's where statistical tests come in. They help us determine the probability that the results we observed could have just happened by chance.
The lecture mentioned Fisher's exact test.
Yeah.
When would we use that one?
So Fisher's exact test, that's particularly useful when you're dealing with small sample sizes or when the expected frequencies in a contingency table are relatively small.
Okay.
It's a way to make sure our conclusions are still valid even when we don't have a lot of data to work with.
So it's like a safety net when you're dealing with limited data.
That's a good way to think about it.
What about the p-value? I remember that being a really important concept.
Yeah, the p-value is key when it comes to statistical significance. It tells us the probability of seeing the results we got, or even more extreme results, if we assume that there's actually no real difference between the groups we're comparing.
So a low p-value means that our results are probably not due to chance.
Exactly.
Is there like a specific threshold for saying something is statistically significant?
Yeah, a commonly used threshold is 0.05. So if the p-value is less than 0.05, we usually consider the results to be statistically significant,
Okay.
which means we can basically reject the null hypothesis, which is that idea that there's no real difference between the groups.
So a low p-value is good news, right? It means that your experiment or intervention is probably having a real effect.
Exactly. It means we're seeing something that's not likely to be random. But if that p-value is higher than 0.05, well, we can't rule out random chance as a possible explanation for what we're seeing.
So our results wouldn't be statistically significant.
Right.
Okay, it's like a high jump competition.
Right.
If you clear the bar, your results are statistically significant. If you knock it down, they're not.
Yeah, I like that analogy.
The lecture also mentioned Tukey's HSD test.
Yeah.
When would we use that one?
So Tukey's HSD test is what we call a post hoc test, meaning it's used after we've done an AMUVA or a Kruskal-Wallis test.
Wait, remind me what those are for again?
So AMUVA and the Kruskal-Wallis test, those are used when we want to compare the means of 3 or more groups.
Okay.
If those tests show us that there's a statistically significant difference somewhere between the groups, Tukey's HSD helps us narrow it down and figure out which specific groups are different from each other.
So it's like we zoom in after we've got the big picture
That's a great way to put it.
and then pinpoint the differences that are actually driving that overall significance.
Exactly. It's like using a magnifying glass to examine the details.
This is all starting to make sense. It's like putting together a big puzzle piece by piece.
Yeah.
Speaking of pieces, the tutorial pack actually had a really cool example. It involved clickstream data from an e-commerce website.
Yeah.
And it focused on analyzing the user journeys through that website, tracking which pages they visited and in what order.
It's all about understanding those patterns.
The goal was to calculate the bounce rate and the conversion rate.
Those are essential metrics for any e-commerce website.
Right, we talked about those earlier. The bounce rate tells us how many people leave after only looking at one page. And the conversion rate tells us how many people actually complete a desired action, like buying something.
That's right.
So in the tutorials example, they calculate the bounce rate by counting the number of users who only visited the homepage and then dividing that by the total number of users.
A simple but effective way to measure engagement.
And then the conversion rate was calculated by counting the number of users who made a purchase, again, divided by the total number of users.
Makes sense.
So it's pretty simple math, counting and dividing.
Uh-huh.
But the insights you can get from those metrics are really powerful.
They are.
A high bounce rate might mean your website isn't engaging, or maybe it's just not relevant to the people visiting.
Right.
And then a low conversion rate could suggest that there are obstacles preventing people from completing those purchases.
Absolutely.
So by analyzing that clickstream data, you can identify these issues and use that data to make improvements.
Precisely.
It's amazing how much we can learn about user behavior just from their actions on a website.
It is.
But, and we've talked about this a lot, it's really important to use this data responsibly and ethically.
Sure.
Respecting user privacy and being upfront about how you're collecting and using information.
I completely agree. Data can be incredibly powerful, but it's up to us to make sure it's used responsibly.
Okay, let's move on to explore this fascinating world of search engines and maybe delve a little deeper into user privacy.
Sounds good to me.
All right, search engines. Before the break, we were talking about, how they use those algorithms to decide which websites appear at the top of the search results.
Yeah, it can seem a bit mysterious.
Very mysterious. You mentioned IR models.
Information retrieval.
Right, IR models.
Mm-hmm.
Remind me what those are and how they relate to search engines.
Okay, so IR models, that stands for Information Retrieval Models. They're the backbone of how search engines actually work, basically connecting users with the right information from this huge collection of online documents.
So when I type a question into Google, it's using an IR model to sort through all the websites and find the answers.
Exactly. And the amount of information that process, it's just mind-boggling. It's like having a librarian who's read every single book in the world and can instantly tell you which ones will answer your question.
That's a great analogy.
Mm.
The lecture slides mention that building these systems involves a lot of different areas of expertise.
Oh, it does.
Database management, informatics, natural language processing, machine learning.
It's really multidisciplinary.
Yeah, and it's not just about matching keywords anymore.
Right.
Modern IR systems actually try to understand the intent behind your search, considering context, synonyms, even your location. That's right.
So if I search for, pizza delivery near me, it understands that I'm hungry, I want pizza, and I want it delivered to where I am right now.
Exactly. It's using those algorithms to give you the most useful and relevant results.
The lecture slides also differentiate between data retrieval and information retrieval. Can you explain the difference?
Sure. Think of data retrieval as searching for a specific product in an online store using its ID number. You know exactly what you're looking for. You just need the system to go fetch it.
So it's retrieving an exact match.
Exactly. Information retrieval, on the other hand, that deals with unstructured data like, say, text documents or web pages. The queries are often more open-ended, and the system has to figure out which documents are most relevant.
So it's more like asking a librarian for books on a specific topic, and they have to use their knowledge to guide you to the right resources.
That's a really good way to put it.
The lecture slides also go into the architecture of an IR system.
Yeah, there are quite a few components. Yeah, there's storage, indexing, query interface, management interface, and text pre-processing. Can you briefly walk me through those?
Sure. So storage, that's basically where that huge collection of documents is kept. It's like the raw material for the search engine. Then there's indexing. Think of this as creating a detailed catalog for that massive library so you can search through it quickly.
So you don't have to read every book to find what you're looking for. You can just check the index.
Exactly. It stores those keywords and their location within the document, so the search engine can quickly find relevant documents without having to scan everything every single time.
Very efficient. What about the query interface?
Ah, yes. That's basically the search bar where you type in your questions.
So like the bridge between me and all that information.
Precisely. And then the management interface, that's kind of like the control panel behind the scenes. It's where administrators can add new documents, update the index, and basically make sure everything is running smoothly.
So like the librarian's office where they manage the whole collection.
That's a great analogy. And lastly, there's text pre-processing, which is a crucial step to get those text documents ready for indexing and retrieval. It involves techniques like tokenization, stemming, stop word removal, and detecting phrases.
Okay, break those down for me. Tokenization, what's that?
Tokenization is like breaking down a text document into individual words or tokens.
Okay.
Stemming reduces words to their base form, like Running, runs, and ran would all become just run.
So the search engine doesn't see them as different words.
Exactly.
Okay.
Stop word removal gets rid of those common words like the, is, words that don't really have a lot of meaning in themselves.
Right. You don't want those clogging up the index.
And detecting phrases is about recognizing those multi-word expressions like, let's say, New York City or information retrieval.
Okay.
That way, the search engine knows to treat those phrases as a single unit, which helps make the results more accurate and relevant.
So instead of searching New York and city separately, it understands New York City as one thing.
Exactly. Text pre-processing is all about cleaning up that text and getting it ready for analysis.
So once the text is all pre-processed and indexed, the search engine can start retrieving documents based on our queries. But how does it actually decide which documents are the most relevant?
That's where retrieval models come in. The lecture mentions several, like the Boolean model, the term frequency model, even things like cosine similarity.
Those sound pretty complex.
They can be.
Should we break each of those down?
We can keep it high level. The main idea is that each model uses a slightly different method for ranking those documents based on how relevant they are to the query.
Okay.
Some models might focus on just the presence of keywords, others might look at how often those keywords appear, or how similar the query is to the document overall.
So different tools for different jobs.
That's a good way to put it. And of course, one of the most famous models is Google's PageRank algorithm,
Oh yeah, PageRank.
the one that really changed the game.
How does it work?
Well, PageRank basically looks at how important a web page is based on how many other web pages link to it.
Okay.
Think of it like a popularity contest. The more high-quality websites linking to your page, the higher your PageRank score, and the more likely you are to show up at the top of the search results.
So it's not just about the words on your page, but also your reputation.
That's right. This is where SEO comes in, search engine optimization. Website owners try to improve their PageRank by getting those high-quality backlinks.
So it's a game, basically, to get your website seen.
It can be pretty competitive, but it's a crucial part of digital marketing.
But PageRank isn't the only thing Google looks at, right?
No, not at all. The lecture mentions that Google uses hundreds of signals in its ranking algorithm.
Wow, hundreds. So content quality, user experience, mobile friendliness, even social media, all these things matter.
Exactly. It's a much more holistic approach now. Websites have to focus on providing value, a good user experience, engaging with their audience in different ways.
This has been really interesting, but as we've talked about throughout this whole deep dive, there are concerns about user privacy with all this data collection.
Absolutely. It's all about finding that balance between using data to improve those services and protecting individual privacy.
The lecture highlighted unauthorized tracking, user profiling, and data breaches.
Big concerns.
Let's revisit those. Unauthorized tracking, what does that mean exactly?
Well, that's basically when your data is being collected without your knowledge or your consent.
Like those tracking cookies that follow you around the internet.
Exactly.
So I might like seeing those targeted ads, but I don't necessarily want every move I make online being tracked.
It's all about transparency and control over our data.
What about user profiling?
User profiling is about building those detailed profiles of users based on what they do online.
Okay.
That might include your browsing history, your purchases, social media activity, location data, all kinds of stuff.
So it's like building this digital version of me.
Yeah, pretty much. And while this information can be used to personalize your online experience and make those recommendations, it also raises concerns about privacy.
Yeah, because what if, my health insurance company could see that I've been searching online about, a particular medical condition?
Right. They could use that information against you, even if you're perfectly healthy.
Scary. We need some serious safeguards in place.
We do.
And of course, there's always the risk of data breaches.
Right. A huge concern. Those data breaches can expose so much sensitive information.
Financial records, medical records, all kinds of stuff.
And that can lead to identity theft, fraud, all sorts of problems.
Okay, so what's being done to actually protect our privacy in this data-driven world?
Thankfully, there are some things in place. We talked about the GDPR earlier.
GDPR, right, in the EU.
Mm-hmm.
Remind me how that helps.
So the GDPR gives individuals more control over their data. You have the right to access your data, correct it, have it deleted, and even move it to another service.
So those sneaky tracking cookies, I can tell them to go away.
In theory, yes. And companies that don't comply with those rules, they can face some pretty hefty fines.
Good to know. What other techniques are there?
Well, one promising approach is anonymization. So this involves stripping the data of any personally identifiable information, making it impossible to trace it back to a specific person.
So instead of knowing it was John Smith who bought something, they would just know that, someone in London bought it.
Exactly. It lets companies get insights from the data without compromising individual privacy.
That's a great solution.
And another important concept is data minimization.
Data minimization, so collecting only what you absolutely need.
Precisely. It's about being more mindful of the data we collect and not just gathering everything we can get our hands on.
It's like a digital version of less is more, right?
Yeah, exactly.
This deep dive has been so insightful. We've covered so much: the technical side of web analytics, the ethical concerns, the complexities of search engines.
It's a vast and constantly evolving landscape.
I'm definitely feeling more informed, but it's a lot to think about. It really highlights the importance of being aware of what's happening with our data, demanding more transparency and control.
Absolutely. Knowledge is power when it comes to the digital world.
So as we wrap up this deep dive, what's the one thing you want our listeners to take away from all of this?
Web analytics is an incredibly powerful tool, and like any tool, it can be used for good or for bad. It's up to us to ensure that it's being used responsibly and ethically. We need to strike that balance between personalization and privacy, between innovation and accountability.
Well said. Thanks for taking this deep dive with us. We hope you've enjoyed exploring the fascinating world of web analytics.
It's been a pleasure.
Stay curious, stay informed, and most importantly, stay vigilant about your online privacy.